In this two-part video, we will show you how to generate material variations for NFTs in Blender using drivers. Using this technique, you'll have the ability to produce dozens, hundreds, or even thousands of unique collections without having to use extensive Python scripting. The emergence of NFTs has provided aspiring artists, especially digital ones, with an opportunity to share their work in new ways, potentially reaching new audiences and communities, as well as finding a new source of income for their work. Most new artists are inclined to create multiple pieces and sell them either in bulk or auction them off to multiple buyers. These are called collections. More often than not, as many as 10,000 different pieces of artwork can make up a single collection. And using Blender can assist in this process. Building a scene with multiple objects and attributes to generate a collection of 3D renders is a very efficient strategy. It may seem tedious, but there are means of automating this process in order to avoid producing this many combinations manually. Though essentially everything you do in Blender is an operation in Python, there is a way to do this without using any sort of extensive scripting. For the sake of new users, the timeline is your way of navigating animation in Blender. Usually located at the bottom of your workspace, it allows users to scrub through a scene to show the state of an animation or simulation frame by frame, set and edit the keyframes of an object, as well as control the start and end frames of a sequence. Though keyframes are not an integral part of animation, yes they are, we will not be using them here. Instead, we'll be using drivers. In Blender, drivers are similar to setting keyframes in the timeline, but with more flexibility. As its name suggests, drivers drive the values and settings of an object and its properties, such as material or visibility. The value of a particular driver can be set by using a driver expression, or, in other words, a script formula that uses other variables and settings. By right-clicking certain properties, either in the outliner or in the Properties tab, you can find the driver option, offering the option to add a new driver or copy, edit, and delete a pre-existing driver. Objects with multiple materials are a great way to create variety in your collection, but drivers cannot be set in the material properties outright. This is where you will need to use geometry nodes. First, you'll need to create a set material index node between the group input and group output node in the geometry node tree in your desired object, tethering the material indexes together in the node tree. There we go. Your tree should look like this. Though not explicit coding, a little bit of script and a little bit of math will be necessary to get the results you want out of your drivers. We will use the global frame expression, so our toggles will be driven by the frame position of our timeline. Since our object has multiple shaders, adding a driver to the modifier can allow us to change the material of a specific frame and scroll through our shader library using a driver expression. Inside our driver property window, you will have the option to augment driver settings by type and value. By default, the driver type is set to script expression. This is what we'll be using. For example, with our 5 possible materials, 0 being the index value of the first shader, we can set our driver to something like this. So first, our global frame expression is set. This means that the driver is meant to think in frames for the expression. The double / is next. This tells the expression to pay attention to the value that precedes it. Usually a single slash is enough for a driver, but material index values are always integers or whole numbers, and not floating points, meaning numbers with decimals. Using 2 slashes denotes that and allows the expression to work properly. Next is my value. As you can see, I've written 5. This means that for every 5th frame in my timeline, the driver will switch to the next material in my library and assign it to the specified object. You can set this value to whatever you wish in your file's frame cycle. Yeah, it works. As you can see, however, once all of my materials are cycled through, the driver operation ends. Since I only have a few materials, I want this cycle to repeat all the way to the end frame of my timeline. The percent operator, or modulo, is what we can use to do that. The value after the modulo denotes how many of my materials I want to cycle through. Since I have 5 materials, my value will be set to 5. With this scripted expression, I can see that my driver is working. Awesome. You can take the time to experiment with these values and find the best expressions for your project. In our next video, I'll show you how to make a driver expression to toggle visibility.